The institutional model that we're going to use is an extension of a very simple classical model by Condorcet, the great French philosopher and proto-social scientist who started two important lines of research in voting theory. The line that we're going to be talking about concerns the common interest problem, not the intransitivity and majority rules problem that inspired Arrow's possibility theorem. So the basic idea behind Condorcet's jury theorem, and it's important just to get the basics straight because the extension that we're going to use is going to build on that. The basic idea is a group of people facing a pairwise choice called the jury theorem because Condorcet was originally thinking of a context of a jury, so you can either make the mistake of freeing a guilty person or jailing an innocent one. A curious historical side note, Condorcet was killed during the French Revolution, and the story goes, I don't know if this is true, the story goes was that he was convicted by a rigged jury. So it's kind of ironic, but so his jury theorem wasn't available really to help him, wouldn't have been implemented if it had been. Anyway, so a pairwise choice considered two alternatives, A and B. It's common interest, so we set aside all the incentive issues. We'll assume that alternative A is the superior choice for the group. And in the benchmark model, everybody is equally competent, that is somewhat better than a fair coin. So with probability greater than 0.5 chooses the correct alternative. And nobody's infallible, so nobody with probability 1 makes the correct choice. And Condorcet's insight was to realize the following probabilistic idea. If voting is independent, if judgment, in a sense, is independent, and the collective choice rule is majority rule, then the more people you have in the group making the decision, the more canceling out of random errors you have. So the probability that the group majority makes a correct choice rises monotonically in the size of the group and gets arbitrarily close to 1 as group size grows arbitrarily big. But the key thing is the first property. You know, since realistic context, we're not talking about arbitrarily big groups. The first property, namely, that group reliability, the probability the group makes the right choice increases steadily with increases in the size of the group. And so in that situation, in that kind of situation, obviously, more centralized systems, that are systems with smaller groups down to 1 in the dictatorship case, more centralized systems are not as good as more decentralized systems. And it's that basic idea that Josh and I are going to be generalizing. Okay. So, simple setting, governing coalition with more than 2 players facing a binary choice between alternatives A and B, common interests, as I mentioned. Everyone in the governing coalition takes a position. Basically here, the setup that we're going to use is a set of assumptions described very ably by Austin Smith and Banks in volume 1 of their book on social choice and game theory, in which basically the rules are simple enough so that everything that you need to know about the process, or we might say the power structure in this situation, is captured by the set of minimum winning coalitions. So if you know the set of minimum coalitions, then you know everything you need to know. So say if you have 5 people and you have simple majority rule, flat system, nobody has more power than anybody else, the set of minimum winning coalitions are simply the 3-person coalitions, ABC, ABD, ABE, BCD, and so on and so forth. And one of the reasons that this is enough, it's just capturing the set of minimum winning coalitions is enough. Those assumptions that you see up there, the process is decisive. So if one coalition wins, the other side loses. If one loses, the other side wins. Everybody takes a position. And the process is monotonic in the sense that if a subset of players is a winning coalition, you add somebody to it, that new coalition is also winning. If I get anything wrong here, David can correct me. Unlike the process that De Baron was describing, there's no status quo, so no alternative is privileged. The model, I think, can be pretty easily extended to that, but that's not what we're looking at. No alternative is privileged, but what we're going to be looking at are situations in which decision makers, certain decision makers are privileged in the sense that they, a particular person, whom we'll call the leader naturally, can have more power than other people. Okay. And since David seems untroubled, I assume that nothing seriously has been wrong said about this. Okay. Okay. So what we'll want to do is define a rank ordering of power in terms of winning coalitions. And the method that we use in the paper is fairly general. In particular, it can represent weighted voting schemes, where, say, the leader has 2 votes and everybody else has 1 vote. But it can also represent sets of minimum winning coalitions that cannot be generated or recovered by any weighted voting scheme. I was first surprised when I read, actually, Austin Smith and Banks, that this was true of systems with this kind of structure, this kind of simple structure. But after Ken Schatz explained to me what was going on there and I understood, I thought it was really quite interesting. And part of the point of this paper, by the way, is that we want to make this usable for comparative political economists who are studying authoritarian systems in which there is no real voting going on in the governing coalition. There are winning coalitions, and there are minimum winning coalitions, and those can be described, but there's not really any voting going on. We don't want this to be metaphorical, so really the fundamental thing of the power structure, the fundamental description of the power structure turns on the minimum winning coalitions, and we don't want to rely on votes. The intuition underlying the power ranking method that we use is pretty simple, and it's based on switching the positions of 2 people, and we're trying to rank order the power of, say, players I and J in the governing coalition. And so what we do is we take a division on what's sometimes called a division on the question. So let's say that players 1, 2, and 3 are on one side, and they vote for A, and 4 and 5 vote for B. And let's say that, in fact, A doesn't win, despite having a majority of the players. But instead, B wins by the support of players 4 and 5. So